So it was fun. So anyway, we're going to be looking at the parabola. This is essentially what we studied in the earlier chapter. I think it was chapter 2 and 3 is where we did the parabola. So this is essentially what we're used to. But the conic sections have parabolas that also go the other direction. But these are not functions, which is why when we did chapters 2 and 3, those were the studies of functions. These guys were not included. And they're called conic sections because they're not functions. So as we know from days gone by, the standard form of the parabola is y equals a times x minus h squared plus k. The vertex is hk. The axis of symmetry is x equals h. General form is y equals ax squared plus bx plus c, and this shouldn't be here. It's equals 0. Those are the x-intercepts. And it opens up if a is positive, opens down if a is negative. The vertex of the parabola is x sub v is minus b over 2a, y sub b is the f of minus b over 2a, and the axis of symmetry is x equals x sub v. So that comes from previous times. Now here's the problem. When you're doing the parabola that opens side to side, it is the same set of formulas, but x and y are reversed. And that's what makes it a little bit confusing. Because in order to get something which is not a function, it's an x equal. And it's x equal a times y minus k squared plus h. K always goes with the y coordinate of the vertex. H always goes with the x coordinate of the vertex. But the vertex, because we're always graphing in x, y coordinate points, the vertex is hk. The axis of symmetry, because this guy runs horizontal, will be y equals h instead of x equals h. Keep the picture in mind and you'll be fine. And the general form is y equals ax squared plus, or x equals ay squared plus by plus c. The x's and y's are reversed. And it opens right if a is positive, and it opens left if a is negative. So it's got the same kind of idea. For me, left is negative, right is always positive. So if you look at the x and y axis, so if a is positive, it's going to open to the right, and if a is negative, it's going to open to the left. That kind of helps you get that orientation, or something to at least attach to it as to how you know which way. And it's still the same thing, but instead of having the x coordinate of the vertex, the y coordinate of vertex is minus b over 2a, because that's the guy that goes inside where the parentheses are. And the x coordinate of the vertex is essentially, it's not a function anymore. You input x sub y into the equation and find what x is. Because you can't say f of the x coordinate vertex. You're essentially going to put in y and get out x. That's the way this guy works. His input is y, and his output is x. So you're going to input y, get out x. So once I know what the y coordinate of the vertex is, you find the x coordinate of the vertex by putting in y and getting out x. Or you can read it off, just like you would here. Only what you're getting is k from the inside and h from the outside. Everything is reversed. So the axis of symmetry is a horizontal line now, so it's y equal the y coordinate of the vertex. In brief, we don't mess with this guy. We don't need to. In the engineering calculus, you can have things going any which way, because you're not necessarily guaranteed you're working with a function all the time. So as a result, with the engineering calculus, you've got to keep track of what X's and Y's, and that's why sometimes we talked about systems of equations yesterday, that sometimes I'm interested in the X coordinate of the point of intersection. Sometimes I'm interested in the Y coordinate of the point of intersection, especially if you've got things opening the other direction. You'll go after Y's instead of X's.